is a question from paper 2 of our recent test. Tripped a lot of people up. I just wanted to go through it because I had some questions about it. Wanted to do that. So in an interview, 4 male interviewees and 5 female interviewers are asked to sit in a row of 9 seats outside the interview room. Well, in general, I like to start by drawing my situation. So there's my 9 chairs. And we've got 4 men, 5 women. Okay, so what I'm going to do is we're going to do find the number of ways the interviewees of the same gender must sit together. Well, if I just pick this as my 4 men, then my 5 females have to sit right there. The other way we could do this is if my 4 men sat down here and my 5 women sat here. Well, the number of different ways that the women could be combined is 5 factorial, because if I put the first woman here, then I have a choice of 5, then I would have a choice of 4, 3, 2, 1, all the way down. And then similarly for the men, they can be combined 4 factorial different ways. So, but there's 2 different options of doing this. So the problem becomes 5 factorial times 4 factorial, and then there's 2 different ways. So that is going to be my answer. Now, I'm lazy, so I'm not going to work out factorials. But 5 factorial times 4 factorial times 2, we get 5,760. So that first answer is 5,760. Now, the next question is find the number of ways if male interviewees must sit together. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, there's only 9. All right, so if we're doing that, so they could all sit here. They could all sit here. They could all sit here. Then they could also all sit here or here. And the last way they could do it would be here. If I look at that, I've got 1, 2, 3, 4, 5, 6 different ways for them to sit like that. And then again, the men are 4 factorial. And then if we imagine that I've got the men as a group, and then the women, 1, 2, 3, 4, 5 women, we could move this group of men again and again and again. So there are 6 factorial, because there's 6 spots now, because we kind of consider the men as a group. And we could bounce them around, but there's 6 different ways to arrange this because now we're down to only 6 options. So again, lazy, 4 factorial, actually not lazy, this was a paper 2 question. You should be using your calculator to calculate these things. So I get 17,280. So my answer for this one is 17,280 ways. Now, the last question is we need to find the number of ways if male interviewees must not sit together. Okay. Then if they aren't going to sit together, we know that there are 6 ways for them to sit together. Right? We also know that and with the women, which is always going to be the easy one, women is going to be 5 factorial different ways of them sitting together. So if the men are not sitting together, then we would have 6 permuted 4 different ways of them not being together. Okay, so if I do 6 permuted 4 ways and I multiply by 5 factorial, because again, there's 6 ways for them to sit together, And if I permute it 4 different ways, that gives me the 4 different ways of them sitting there. And then all we have to do is figure out what that is. And I think when I figured out this problem, I already had it up here, but we can just do it. So if we do NPR of 6 comma 4, and I multiply that by 5 factorial, I end up with 43,200. 43,200 different ways for them not to sit together. Okay, I hope that explains it and it's helpful.